Hello geometry students and welcome to today's lesson. Today we're going to be covering 10-3, which is using chords. How chords are used in a circle. So as a little bit of a review, we were talking about a chord, and the largest chord in a circle is the diameter. It has the endpoints on the circle and it goes through the center. So this is the largest chord. And this chord is going to divide this into a semicircle of blue and the semicircle of red. And we talked about those being 180 degrees. Now looking at the second one, you see that chord, and the chord has a minor arc right here. And we said we name the minor arc with 2 letters. And if we're going to be naming a major arc, we need 3 letters. So if this is point A and this is point B, we'd have to have a point in between to say we're going from A to D to B. So major arcs, minor arcs, and circles. All right, so in the same circle, if 2 arcs are congruent, if and only if their chords are congruent. So if we look at this, we have central angles. This one's marked congruent to this one. So going out to this circle, we have this arc right here, XY. So arc XY is going to be congruent to arc WZ. Now, look what happens in between. If we're looking at the length of the segment WZ, that chord length is marked congruent to that chord length XY. So what's going to happen is this central angle, the chord, and the intercepted arc end up being congruent to its counterpart on the other side. So the green marks, the blue marks, and then the single purple marks. All right, so if we have a circle with the center here, and this is not going to be super accurate, but I'm going to do my best, and we make a diameter here. So now if we just take that diameter and we make any chord, okay, so I'm just going to randomly make that chord that's going to cross this. And if this comes down and we find out that this diameter bisected this chord JK, so we have the chord JK, and if it bisected the chord so that JM is congruent to MK, what do you think has to be happening between that diameter and the chord? If it is going to bisect that chord like it does here, then this diameter must be perpendicular to that chord. Okay, also vice versa the other way. If we have a circle with the diameter and a chord coming down, and I'm telling you that this is perpendicular, what do you absolutely know has to be true about this part of the chord and this part of the chord? They must be congruent. So that's what this is saying here. If we have the diameter that comes down perpendicular to a chord, it is going to cut that chord in half. And because it's an if and only if, that means it's true the other way too. So if the chord is bisected, then the diameter must be perpendicular to it. All right, so this we've already talked about here in this chord. If we've got A, B, and C, D, we have these 2 chords, and they are equidistant from the circle, then that chord AB must be congruent to the chord CD. Okay, and vice versa the other way. If AB is congruent to CD, then they must be equidistant from your center because it's an if and only if conditional statement. All right, so how do we now put this to use? All right, so in this circle here, we want to solve for FH. So we want to know that whole length of FH. And normally we sit here and think and think and think, and I have someone come up to the smartboard and try and figure this out. And this is probably one of the ones that take the longest for kids to figure out here. So they're telling us that we know that XY is 10, And we know that from X to E is 26. Now, what does X to E represent? What is XE of the circle? XE of the circle is the radius. Okay, how is that going to help me? What radius can I draw in to help me figure this out? Well, if I draw in this radius from F to X, that is a radius. And now we know, because EX is 26, we also know that XF has to be 26. So now we're missing one piece, FE, FY. So can't we use our Pythagorean theorem here and say 10 squared plus FY squared must be equal to 26 squared. And this is probably one of the least intuitive things for kids to see. Like I said, most of the time we have to sit here for quite a while for someone to figure this out. So we've got 676. I'm going to subtract 100 from both sides. So FY squared is going to be 576. So we're going to take the square root of both sides, and FY technically is going to be plus or minus 24. But because we're talking about a length here, we're not going to use that negative value. So we're only going to use 24. So FY is 24, but they're really looking for FH. And because that diameter is perpendicular to that chord, we know that that chord is being bisected. So if that side's 24, then this side is also 24. So FH must be 48 units. Okay? All right. On this next one here, we're talking about chords in a circle. If chords are congruent, then their arcs must also be congruent. Okay, so if we have a chord in here and we're marked off that NP is 130 and that length is 9 and MN is 9, then this is also 130. So then how can we find the measure of MP? Well, we can take 360 and we can subtract 130 and subtract 130. And what are we left with here? 0, 0, 100 degrees. Okay, so that's what this lesson is talking about. Now there's one other thing in here too, and it says find the measure of angle MNP. This is something that we're going to be doing next week when we're finishing up this chapter here. And they talk about inscribed angles. So we're going to talk about that later. It's not going to be on this test coming up in here. All right. This looks like a big old mess, so some of you might want to pause this and look at it, but we'll come back and we're going to figure this out. They want us to find the radius of the circle. So what information do they tell us here? Well, they're telling us that QR and ST are definitely congruent. And if you see that red line comes down perpendicular and the blue line comes down perpendicular. So that means that they are equidistant here from the center, because if that comes down perpendicular, it is bisecting those. And if it's bisecting those and we know the chords are congruent, then they have to be equidistant from the centers. So that means that 5x minus 9 has to be equidistant to 2x. So I'm going to subtract 2x from both sides, and I'm going to add 9 at the same time. So I end up with 3x equals 9. So x is 3. How does that help us? Well, that helps us in the fact that now we can find out that this length right here, 2 times 3, is 6. And up here in the beginning, they tell us that this whole segment right here is 16. So remember, if that comes down perpendicular to it, we know that this piece right here has to be 8. And then what can we do? We're trying to find the radius of the circle. So if I connect C to R, is that my radius? And now do I have a right triangle here of UCR? So can't I use my Pythagorean theorem? 6 squared plus 8 squared, isn't that going to equal CR squared? So we have 36 plus 64, so we've got 100 equals CR squared. So we're going to take the square root of both sides. And remember, technically, it's plus and minus 10 is what CR's length is. But I don't think we can use that negative 10. So we're going to find out that the radius of this circle is 10. All right, so that should be using all of our theorems in this section right here. All right, now I am telling you right now that number 21 on your homework is going to be a challenge. Number 21. So they're going to give you a circle and they're going to tell you that this diameter is 20. Now you're going to make another chord, and that chord is 16, and another chord down here is 12. And they want you to label these two things, A, B, and what they want to know is what this right here is going to be. They're looking for A, B. Okay, now remember some different tricks and things that we can do. So if that's a diameter, can't we make a radius so that this radius comes down straight? And if it comes down to be perpendicular, what is it doing to that side? Now, my little hint here is that we can make up two different triangles here. So if I look at this red triangle here and I go from here out here to A. Okay, now if I extend this down right here, okay, if I find out what that angle, what this central angle is, isn't that the measure of this whole arc right there? Let's just put a C there. So can I find out what arc AC is if I could find this central angle? Now remember, they're telling us this diameter is 20. So isn't this point to this point a radius? So isn't this 10? And if this whole thing is 16 in here, isn't this piece right here 8? So using your sign, can't you find out what this angle is in here so you can find out what arc AC is? Now, you can do the same thing from B. So if you draw in this right triangle here, well, this radius hasn't changed of the circle. That radius is still 10. And now this piece down here is 6. So can't we find out what this angle is in here? And if you take that big arc, that central angle of AC, and you subtract that BC from it, aren't you left with what AC is going to be? All right, so that's my hint for number 21. And I think in the book they may have rounded to the 100th place, so round 2 places past the decimal. All right, good luck. This is using chords.